Let's talk about the first step of factoring, which is to find the greatest common factor. The first thing we must always do when factoring is to look for a greatest common factor. The greatest common factor is something that is part of every term of the polynomial. For instance, for our first problem, this binomial 5x plus 5, there is a 5 that is clearly part of each of these terms. So our greatest common factor is 5. Let's undistribute that 5, dividing each term by 5. Now, as we factor, we want to have an equivalent expression. So as we undistribute, we'll put that 5 out in front, multiplying what is in the parentheses. So if we take 5x and we divide by 5, we would be left with x. And if we take 5 and divide it by itself, we get a positive 1. Notice that we had a positive 5 being divided by a positive 5, so this gives us a positive 1 result. For the second problem, we again have a 5 that is common, but this time as we divide the common 5 out, 5x divided by 5 leaves x, but back on the back, negative 5 divided by a positive 5 gives us a negative 1 result. So 5 times x minus 1 would be our factored form. Now, I've noticed on these first two problems that the leading coefficient has been our common factor. It's not always going to be the leading coefficient, though. On the next problem, 8x minus 12, notice that 8 will not go into 12. So we've got to find something else that is part of each of these terms. Since they are both even, I know that 2 will go into each thing. But remember, we want the biggest thing that is part of each term. Can we do better than 2? There is 4 that is part of each thing that's here. So our common factor then, the greatest common factor that we can take out is 4. Let's divide each term by 4. 8x if you divide by 4 leaves us 2x, and minus 12 if you divide by 4 gives us minus 3. Notice for each of these problems that if I multiply back into the parentheses, I should get back to where we started our problem. 4 times 2x is 8x. 4 times negative 3 is negative 12. Look at the next one, 7x plus 11y. The only thing that is common to each of the terms is a 1. This one cannot be factored any further than where we are right now. The word that we use to say that it cannot be factored any further is prime. Now, before you call something prime, be sure that it is prime. One of the main reasons that you're taking this course is to learn to factor things. So most of the problems that we're going to see are going to factor in some way. Be very careful before you say something's prime. Well, all of our problems so far have just had two terms, binomials, but our problems could get bigger than that and have more variables involved as well. For the next one, first, let's look at the coefficients and see what number goes into each of them. 20, 25, and 30 can all be divided by 5. So since 5 is part of each of these terms, I know that 5 will be part of my greatest common factor. Next, let's look at the x's. Notice that each term has an x as part of it. They, in fact, all have an x cubed that's part of them, but they don't all have an x to the fourth. They don't all have an x to the fifth. So looks like x cubed is the most we can take out for the x's. Notice that everybody here has a y as well. They all have at least a y square. They don't all have a y cubed or a y to the fourth. So looks like y square will be part of our greatest common factor. Now think about what we've said with those variables. It's actually the smallest of the exponents that serves to be our greatest common factor. The smallest of the x's was x cubed. The smallest of the y's was y squared. While it sounds strange to say it, The smallest of the exponents is the greatest common factor. So our common term then would be 5x cubed y squared. Let's divide each part by that. 20 divided by 5 is 4. Remember that we subtract exponents when dividing, so x to the fifth divided by x cubed leaves us an x squared, and the y squares divide out for the first term. In the middle, 25, if we divide by 5, is 5. Again, subtracting exponents, x to the fourth divided by x cubed leaves just an x, and y cubed divided by y squared leaves just a y. On the back, 30 divided by 5 gives me 6. Looks like the x's are going to divide out, and y to the fourth divided by y squared would leave us y squared. Again, if we multiplied back into the parentheses, we could get back where we came from. Let's try one more. 12 minus 18 and 6. Looks like 6 is the common term for the coefficients. What's the smallest of the x's? Just an x. What's the smallest of the y's? Just a y. So our common term is 6xy. Notice that that's the last term of this trinomial. Let's divide each term by 6xy. 12 divided by 6 is 2. Subtracting exponents, x to the eighth divided by x leaves x to the seventh. Y to the fifth divided by y gives me a y to the fourth. In the middle, negative 18, if I divide by 6, is negative 3. X cubed divided by x, 3 minus 1 gives us 2. And y to the seventh divided by y, 7 minus 1 leaves us 6 for the exponent there. Now, back on the very back, if you divide something by itself, you would get 1 as the result. Very common for people to forget to put that 1. You have to have the 1 because remember, when we multiply it back out, we want to get back where we started from. If we don't put that 1, then we would not be able to multiply back into the parentheses and get this 6xy at the back. So we have to have that 1 as part of it. The first step of factoring is to look for a greatest common factor, something that is part of every term. For the variables, it's actually the smallest of the exponents that is the greatest common factor.